So today I'm talking about X and Y intercepts, and this is going to be in context of our graphs, equations. We're going to be dealing with function notation. So I know function notation is really difficult for a lot of people, so hopefully seeing it used here will help you out. So first, when we talk about X and Y intercepts, what exactly are we talking about? What are intercepts? So when you graph an equation, often your graph is going to cross or intersect one of our axes, either the X or the Y. Sometimes it does both. Sometimes it doesn't intersect any of them, but it often does. And so where these graphs cross the axis are called intercepts. So linear equations have two intercepts. So if I was to have my x, y, and I was to graph a line, it goes through the axis at 2 points, once on the y and once on the x. So there's two intercepts there, one for x, one for y. There are special cases. Horizontal and vertical lines only have one intercept, but for the most part, linear functions have two. There are, excuse me, there are other functions that may have more than one number of intercepts. So if I was to graph a polynomial, which you'll be learning about soon, a polynomial is usually kind of curvy, so there may be one intercept on here, but sometimes it can curve and go elsewhere, so you could actually have, let me actually draw a better one. Let's say I can squiggle multiple times. It doesn't actually go back on itself. Okay, there we go. So a polynomial can squiggle back and forth, and it can actually cross the x-axis multiple times. So there's more than one x-intercept for something like that, but there's one y-intercept. So there's all these different types of functions, and that basically they usually have at least one intercept. For a function where, like this polynomial here, we often refer to things called zeros, and those are essentially the x-intercepts. But zeros are specifically where the function is equal to 0, and sometimes you get answers when you're solving that are complex numbers. But any real valued intercept, or 0, something that's not complex, is going to be an intercept. So those are intercepts. They're just intersecting our axis. So we have the x-intercept and the y-intercept, usually more than one x if we're going into really fancy things. So an x-intercept, that's where it's intersecting the x-axis. So if I was to draw my graph here, and I had, say, a graph like this, there are two x-intercepts. That's where it's crossing on the x-axis there. So it's a point a comma 0 because the y value is 0 there. So graphically, that's what it looks like. When you have an equation, you find this value by replacing y with 0, or if it's in function notation, you replace f of x with 0. And then you're solving for x. Now, the other kind, the y-intercept here, so let's draw a different type of function here. This is where it crosses on the y. That is the y-intercept. So that has a 0 for the x value and then a number for the y value, so we refer to that as 0, b. And you find this value by plugging x equals 0 into your equation, and then you solve for y. Or if it's in function notation, you plug in x equals 0 and you're finding f of 0. So that's how you're going to find the x. The x means y is 0, and the y-intercept means x is 0. So you're kind of taking the opposite. The name of it, the other variable, is 0. So we're going to just start with some graphs, and then we'll move on to equations. So we're going to estimate x and y intercepts. So the first one on the left here, we have a line which has one x-intercept and one y-intercept. So the x-intercept is where it crosses the x-axis there. So that's at x equals 1. So sometimes you can say it's x equals 1. Otherwise, we write it as an ordered pair, 0, 1. The y-intercept is where it crosses the y-axis, so that's at -2. So the y-intercept is y equals -2, but we write this as an ordered pair, 0, -2. So you're going to have to pay attention to Alex and how Alex is asking the question to find out if you're writing your answer as just a number or if you're giving it as an ordered pair. So you're going to have to just kind of see when you click in the box, if they give you parentheses as options, you're going to put them in as ordered pairs. If when you click inside the box to put your answer, there's no parentheses, then you're going to just kind of enter in the numbers. If there's an equal sign, then you put in the equation. Otherwise, you just put in the number. So just kind of watch out for that when you're doing the homework. You want to kind of pay attention to see what you're given when you click inside the box, because that will help determine what form they want the answer to be in. So on the right here, this is a more complicated function. And so we've got x-intercepts. We have one here at -4. And then another one here at 4. So this one has 2 x-intercepts. So usually we would say x equals -4 and then 4. You'd put kind of a comma there. Otherwise, you know, if Alex doesn't give you an equal sign, you would just put in -4, comma 4. Otherwise, in ordered pairs, we would have to write them as 2 ordered pairs separated by commas. So you would have -4, comma 0, parenthesis 4, comma 0. Then the y-intercept here is there up at 3. So the y-intercept is y equals 3, which we write as 0, comma 3. So in this case, the second graph, we have 2 x-intercepts, 1 y-intercept. For functions, you never have more than one y-intercept, because then it's not a function. So we are focused on functions in this class. So functions never have more than one y-intercept. So if it does, it violates the definition of a function. But we can have more than one x-intercept, and we often do. Are there any questions so far? Okay, so moving on, I've got a couple more graphs here. So on the left, that is a polynomial. That's one of those squiggly ones I was attempting to draw really badly. So our x-intercepts, looks like we've got one approximately at -3, and it looks like it's a little bit past -3, and on the right it looks like it's a little bit past 3, but we're estimating, so we're going to round to a whole number because that's easiest here. And we also have an x-intercept here in the middle at 0, because it doesn't cross it, but it does touch the x-axis, and that's still considered an x-intercept because it got there. You know, maybe it didn't go all the way above and it just turned around again, but it did indeed get to that point. So this has 3 x-intercepts. We have -3, 0, and 3. And I'm not going to bother writing these in ordered pairs. So y-intercept actually is right on top of our x-intercept there. So it only crosses the y-axis at the origin. So that x-intercept is also a y-intercept. So that's y equals 0. So you could have an ordered pair that's both, and that generally only happens when it's at the origin. On the right, we've got what is called a step function because it kind of looks like a staircase as it's going up. And if you notice, for x-intercepts, it does not cross anywhere. It doesn't actually go through the x-axis at all. So there are no x-intercepts, and that is completely possible. So there is none because it doesn't actually hit on the x-axis there. For the y, so y-intercept, it does right here at -1. So that would be y equals -1. Any questions so far? All right, so we're going to move on to the algebra portion, where we're actually given equations. Because if you've got the graph, you can just look at it and you can read it off of the graph. But when you have an equation, you have to know what the steps are that you're doing to solve to find your x and y intercepts. So I'm starting with a linear function here, and all of these are in function notation so that you can practice getting used to function notation. So we're starting with a linear function. So it's a line because it's in mx plus b form. It's got 3x minus 12. And function notation is where you have a letter parenthesis x. So we got g of x. And so that's telling us this is a function. So for the x-intercepts, that is where y is equal to 0, or in our case, your function, which is called g of x, is equal to 0. So you basically take your equation, you set it equal to 0 to solve for an x-intercept. So I have 3x minus 12 equal to 0. And then I'm going to solve this equation for x. So I will add 12 on both sides. We have 3x equals 12. And then you divide both sides by 3, and you get x is equal to 4. So our x-intercept is at 4, 4, 0. Now the y-intercepts, or intercept, that is where your x is equal to 0. So we're going to replace x with 0. So we have g of x, and when we replace that with 0, we're finding g of 0. So g of 0 equals, and then I replace x again with 0, so it's going to be 3 times 0 minus 12. And when you are evaluating a function, which evaluating means you're just finding the answer, you're only doing the stuff on the right side. You're following the order of operations. So we're not solving here. So I multiply 3 times 0, which is 0, and then I'm just left with negative 12. So our y-intercept, you could say it's g of 0 equals negative 12, or y is negative 12. So the key here that I want you to remember, to find x-intercepts, you solve for x. To find y-intercepts of a function, you don't solve. We're not solving, we're just following the order of operations on one side of what we have. So that's the difference there. And you can check your work with using a graphing calculator. And so I do strongly recommend doing so. So I'm going to pull up Desmos, and I'm going to just click graphing calculator. And then I'm going to type in my equation. And you can use function notation. So it's at g parenthesis x parenthesis. You can type it in exactly like that, equal 3x minus 12. Whoops, not minus 121. So our x-intercept, you can see this is where it's crossing the x-axis. I highlight it. It tells me it's 4, 0. That matches what we got when we solved. And then I can zoom out, and then this is our y-intercept, which is 0, negative 12, and that's what we got when we plugged in the value for 0 for x. We plugged in, we got negative 12 out. So you can use Desmos to double check your algebra to make sure that you've solved correctly. And then if it doesn't match, well, that tells you, okay, I need to go back and see where I messed up. Are there any questions? Okay, so this is where we're going to get into using all of the different types of solving equations that we did basically the first half of the class. So first half of the class, we learned how to solve a linear equation, quadratic equation, absolute values, radicals, rational equation. We've learned a whole bunch of different types. So second half of the class, you're looking at graphing all of these different types of functions. And we often want to find x and y intercepts. So that's why we had to learn how to solve them, because we need to know how to solve first before we could learn how to find the intercepts. So we've got here an absolute value equation, and it's an absolute value function. It's in function notation. And we have k of x equals negative absolute value of x plus 2. So x-intercepts are usually the hardest to find when it comes to functions. Linear is no problem, but anything beyond linear, I shouldn't say that it's hard, it's just you have more steps. It's the longest to find. So to find the x-intercepts, that is where you set your function equal to 0. So we're going to make k of x equal to 0. So I'm going to get this equation, 0 equals negative absolute value of x, absolute value plus 2. now we have an absolute value equation that we want to solve. So that's why you had to learn how to do these. So I'm actually going to move the absolute value so that it's positive and on the left, just because I like to have positive things in front of what I'm solving for. So that gives me the absolute value of x is equal to 2. So now remember, when you have an absolute value equation, when you take away the absolute values, you get two equations, one with a positive, one with a negative. So we get x equals positive 2, and then we get x equals negative 2. So we have two x-intercepts here at 2 and negative 2. So I'll just put these as ordered pairs. So that way when you compare it with Desmos, you'll see those are the ordered pairs. Those are our x-intercepts. For the y-intercept, that's where we plug 0 into the function. So we're finding k of 0. So I have negative absolute value of 0, absolute value plus 2. So the absolute value of 0 is still 0. So this gives me negative 0 plus 2. And negative 0 is 0. So this is just 0 plus 2. It's just 2. I mean, I don't have to show all of that work. I can just say, oh, you know, the 0, it's all going to disappear. My answer is going to be 2. So the y-intercept here is 0, 2. Because remember, your y-intercept, the y is the output, and the function notation is also output. So they're equivalent. They basically mean the same thing. We're just using different notation for it. That's all. So we have two x-intercepts, one y-intercept. So I'm going to hide that graph, and I'm going to type in, we've got k of x, help if I could spell correctly, negative absolute value of x plus 2. So you can see that we've got two x-intercepts here, and when I hover over them, we get the same ordered pairs that we did. And then we have one y-intercept at 0, 2. So the graph matches what we solved for with algebra. Are there any questions?
Could you show that last graph for a quick second, please?
Sure. Yeah, so I've got it graphing. I just typed in k of x equals negative absolute value plus 2, and then this is what the graph looks like when you graph it.
Thank you.
You're welcome. Any other questions? Okay, so I'm moving on, and I'm going through different types of functions here. So we're going to basically be practicing a lot of our graphing, or a lot of our solving that we've done in the first half of the class. We're now practicing those skills. So this function is q of x equals x squared minus 8. And the whole reason why we use function notation is to give functions different names, so that you know that it's a different equation because it has a different name. And it also makes it really nice when I'm graphing in Desmos, because Desmos is not going to get confused between, if I tell it I want a number, do I want this one or this one? If I named them both g, it will still graph it, but then if I wanted to find g of 2, which one am I talking about? You can see it gives me a little question mark. It's like, you've got more than one name here. I don't know which one you're talking about. So that's why we use these different names and use function notation. Because if I have a different equation, it has a different name, and then it's like, oh, okay, you want to plug 2 into this one. So that's one of the benefits of using function notation and why you're learning it. And if you're going into computer programming, this notation actually should be very familiar because you'll be doing things like this all the time. So back to this, we have q of x equals x squared minus 8. So there's no reason that I have to start with the x-intercept. I could do the y-intercept first and then the x, but I just always go with the x because it's alphabetical order. So that is where you're setting your equation q of x here equal to 0. So I'm going to get 0 equals x squared minus 8. So we are solving a quadratic equation here. So when you're solving problems like this, you have to, you know, I don't know if you want to say it in your head or you write down on a piece of paper, but you need to like look at it and be like, ah, this is a quadratic equation. Just like the other one. If I can get there we go. You look at it, you say absolute values. Ah, this is an absolute value equation. So you need to then say, okay, how do I solve these types of equations? So absolute value equations, we have one way to solve. Quadratic equations, there are multiple ways. You can try factoring, you can try the quadratic formula, you can use the square root property. So you need to be able to recognize this is quadratic, then go to your area of your notes. So these are the different ways we use to solve these. Which method is the best way? And I believe in one of my videos, I actually have like a screen that says, if it looks like this, use this method. If it looks like this, use this method. And I have like a chart to help you decide. So in this case, if there's no middle term, it's easiest to solve by taking square roots. So that's the method that you want to do. And so you want to get into that habit where you look at it, you identify what type of equation it is, then you say, how do I know how to solve this? What are the methods that I know? What do I know about those methods? You know, which one is the best method? That's the problem solving process that you want to get into and that you're learning here. So when you're solving by taking square roots, you need to get the squared part by itself. So I'm going to add 8 to both sides. And this gives me 8 is equal to x squared. And so now I'm going to take the square root of both sides. So the square root of 8. And I'm actually just going to flip it so that my x is on the left. And when you're solving, you get a plus or minus. So we have plus or minus the square root of 8. And we need to simplify this square root. So 8 can be split up so that it is 4 times 2. And I can take the square root of 4. The square root of 4 is equal to 2. So our answer here is plus or minus 2 times the square root of 2. Those are our x-intercepts. Those are the exact values here. If I was to graph this, I'm not going to get exact values. So I'm going to q of x equals x squared minus 8. So if you use graphing, it's going to give you these decimals. We don't want decimals because it rounds. And if you have to do a lot of math and you're working with something that's rounded, it could cause you problems, especially if you're doing it in engineering. You know, if you round too many times, your numbers could end up too far off and it could really mess things up. So we don't want to just rely on the graph and get these decimal numbers. We want the exact values. So it gave us a negative 2.828 and 2.828. If you put in your calculator 2 times the square root of 2, that's the same answer you're going to get, but with a lot more decimal places. So we want the exact values because there are a lot of fields where you want to be exact as possible just to avoid any potential errors. So that's why you need to learn how to do this by hand, and you can't always just rely on technology because it's not going to give you the exact value and it could cause you problems. If you're interested, you could Google about rounding errors and math and like things like that and find a whole bunch of stories. I mean, there are hackers that have taken advantage of rounding issues to make millions and steal money. Like it's a big thing. So if you're interested, you can look into that. So those are our x-intercepts. We have 2. And if you were to put these in ordered pairs, you would put 2 square root of 2 comma 0. And then you would have negative 2 square root of 2 comma 0. So that's how you would enter it if you want it as an ordered pair. And you have to make sure that your comma is outside of your square root, because otherwise it does get marked wrong. So then we've got our y-intercepts, or intercept, because there's only one. And so that is where you plug 0 in for x. So if q of 0 equals 0 squared minus 8. So 0 squared is 0, so we're just left with minus 8. So as an ordered pair, that's 0, negative 8 as our y-intercept. And that matches right here, 0, negative 8 when you graph it. So the y-intercept stuff is really quick. You see, like, finding the y-intercept is like 2 steps. It's finding the x-intercepts that are the lengthier amount of work here. Are there any questions on this example? All righty. So moving on, now we have one with a square root. So we want to determine the x and y intercepts of p of x equals the negative square root of x plus 3. So x-intercepts. And if you notice, a lot of these basically have 2 x-intercepts. It's very common. So that is where you take your function, p of x, you set it equal to 0. So 0 is equal to the negative square root of x plus 3. So now we have a radical equation because you've got this radical in your equation. And we solve these by squaring, or if it's like a cubed root, then you cube both sides. And these we have to be careful because you sometimes get extra solutions. So we do have to check your work. And in this case, because we're talking about things that are graphed, I would use the graph to check your work versus doing it with algebra. So I'm going to add the square root of x to both sides just so that I have it positive instead of negative, instead of moving the 3. So that gives me the square root of x equals 3. And then to undo, you square both sides. Undo the square, so, or undo the square root, you square. So that will cancel out the square root and give us x equals, and then 3 squared is 9. Now, it is possible that you get extra solutions, so we're going to use the graph to check. Our intercept should be 9, 0. So I'm going to pull over Desmos and type in my new function, p of x equals negative. And then if you want a shortcut for the square root, it's sqrt. And then it will convert it to the square root symbol, x. And then I got to get outside of my square root, and then I have plus 3. So we found our x-intercept to be 9, 0. So we can use the graph to verify, and it is indeed 9, 0. So good, we didn't get any extra numbers, so our x-intercept is good. So now we want to find the y-intercept, and you can see on the graph it's going to be 0, 3, but we should also do it on algebraically to verify. So our y-intercept, you plug in 0. So if p of 0 equals negative square root of 0 plus 3. And then, of course, square root of 0 is 0, negative 0 is 0, so 0 plus 3 is just 3. And so this gives us for our y-intercept 0, 3. Any questions? All right, so I've got one last example, and this one's actually a word problem to give you an idea of why in the real world you would want to find x and y intercepts. Or in this case, we're not using x and y, we're using different numbers. So this comes from the textbook. A student decides to finance a used car over a 5-year, 60-month period. After making a down payment of $2,000, the remaining cost of the car, including tax and interest, is $14,820. The amount owed is y equals a of t. So this is just telling us that we're using function notation. A of t is the same thing as y. And it says in dollars. So that's telling us our output is measured in dollars. So it's given by a of t equals 14,820 minus 247t, where t is the number of months after purchase. And then because it's a 60-month period, it's going from 0 less than or equal to t less than or equal to 60. Determine the t-intercept and the y-intercept and interpret their meanings in context. So we have a graph here, and we could use the graph to see our intercepts. But I want to actually solve them as well using algebra just to get some extra practice here. So instead of x and y, we're calling them t, and then they're still using y because y equals a of t. So t is just going to be our input x. So even though it's not x, it's still the same thing. The rule is still the same. You set it equal to 0. So to find the t-intercept, a of t is going to be set equal to 0. So I've got my equation 14,820 minus 247t equal to 0. So we're going to solve for t. So I'm going to actually add 247t to both sides. As I keep saying, I like to have positives. I don't like to have negatives. So that gives us 14,820 equals 247t. Then I'm going to divide both sides by 247. And we get t equals, grabbing my calculator, 60, which makes sense because it's a 60-year loan. And that matches with, what we see on the graph here. So that's our t-intercept, and it says interpret their meanings in context. So that means you're writing a sentence that tells us what this means in terms of the problem. So the t-intercept, I'm missing letters, the t-intercept is, if we wrote that as an ordered pair, 60, 0. So 60 is the number of months, 0 is the amount owed. So after 60 months, $0 are owed on the loan. That's what this intercept is telling us. So after 60 months, $0 is owed on the loan. So this is really helpful because let's say you didn't have this type of equation. It wasn't linear. It was something more complicated, where you have like compound interest, which is more common in the world. If you can figure out what the equation is used to get your, to pay off the loan, you can find out how many months it will take. And usually on a car loan, they tell you how many months it is. But let's say you have a credit card and okay, this is how the interest is being charged on the credit card. This is how much I'm going to pay every month, and I'm not going to put any more money on this credit card. So it's only going to go down. You can write an equation and then find basically your t-intercept to find when it's going to be paid off. How long will it take you to pay off that credit card? So understanding t-intercepts or x and y-intercepts are really helpful in real life because they tell you something. They give you useful information. So second part is to find the y-intercept, and then we need to interpret that. So of course I can find the y-intercept just at the graph. The graph, it looks like it's at 15,000, but we want to use the equation. So that is where you set t equals 0. So a of 0 is equal to 14,820 minus 247 times 0. So 247 times 0 is 0, so we're just left with 14,820. So our y-intercept is actually 14,820. The graph makes it look like 15,000, but it's not. So that's why you want to use the equation, because that actually gives you the exact value versus a rounded value that could be inaccurate. So what does the y-intercept mean? So we've got the y-intercept is 0, and then that's money, 14,820. So t is time. So at time 0, it's telling us the amount owed is 14,820. This is basically the amount owed at purchase, because time 0, you just literally bought the car. You haven't, no months have gone by. So at purchase, the amount owed is 14,820. That's what the interpretation is. So at purchase, 14,820 is owed. So a use for something like this is, let's say you don't know, how much it was originally at purchase or something like that. Like maybe you inherited a car and you inherited the loan off of someone. You can use 2 ordered pairs for like, okay, this is how much I owe this month. This is how much I owe this month. And then you can get an equation for a line and work backwards to find out how much the original loan was. So you can actually, if you can get an equation, and that's actually what our discussion is this week, is basically to get 2 ordered pairs, write an equation of a line through there. So this is a similar situation. And then in our discussion, you're predicting you're moving forward in time, but you could use it to move backwards in time to figure out what was it at time 0, which would be, at the time that it was originally, the loan was originally made. So very, very useful stuff, these x and y intercepts, especially once you've got in a real world context and you see what it means. So are there any questions? Okay, so that was basically X and Y intercepts. I'm going to have an announcement in the class, but just to let you guys know too, well, since you're, here live, I have family in town. They're actually coming in kind of, I don't know, they didn't tell me what time they left, maybe 5 or 6 today. So I've got family coming in to visit, and they're going to be in for a week. So I'm still going to be checking my email, but there is going to be somebody in charge who's going to be able to like check on grades, be in the discussions, answer questions like that next week while I'm with my family, spending time with them. But I will be back. I think they're leaving on Sunday. So Sunday, not this Sunday, not tomorrow Sunday, the following Sunday, my office hours will be normal office hours because they'll be gone by then. And I'm still going to be doing a live for week 6. I'm just going to be doing it on the Monday after they leave. So that information is in the announcements. I've already set up the week 6 announcement to have that information. But just wanted to give you guys a heads up. So I'll still be on my phone. I'm still going to be sending things out through Remind and all that kind of stuff. But I'm not going to be at my computer 24/7. I'm going to be spending time with family. But I'm still available. So just a heads up on that. All right. Well, I'm going to let you guys go and enjoy the rest of your Saturday. I'm going to make sure this video gets prepped, posted, all that kind. Yes, the time of the live that week. So it will be, I'll just bring up my calendar. I'm going to find out where my calendar is. I have too many things open. Do I have my calendar open? Yeah, so let me just share my screen so you can see that. Maybe. Okay. So they're leaving on the 19th. So this is during week 6. So the lives are going to be, our live for 105, this class is going to be at 6 p.m. And then I have my normal office hours. And then I have my other class. I have my live right after that. So I'm going to be very available Monday night. So it will be in the week 6 announcement. But you can write that down now so that you know it's going to be on the 20th at 6 p.m. Central Time. And then it will be back to normal Saturday time. So week 7, I'll have it on Saturday again. Because, that thing's at 3. So I should still be able to do Saturday. I just haven't put it on my calendar yet. So, yep. And I'll try to pop into the class and send an email about it too, just to be safe, so. Because I will be having, I could have some access at a computer. I just know we're going to be pretty busy. Do you guys have other questions? All right. Well, I will let you guys go, and I will talk to you when I talk to you next. So you guys take care. Bye.